Hi sir, good morning. So today we're going to explain through our comprehensive data preprocessing and classification workflow using the mental health data set. We will be handling missing data, converting text into numerical representations, and building two models. One is decision tree and another one is neural networks. So in here, we're using NumPy, Pandas, and Matplotlib for our import libraries. So in the first step, we're using a pandas function to read our CSV, and we print the data function out of the information it. Then we set out a function here to check any of the missing values in the data set. So in the next step, we print it out. So here we can have a look on it. Is the statement have 366 of the missings and status is 31 of missing value there. In the next step, we handling the missing data. So we fill in all the NA in the statement, which is there is a missing value there. Then we check on the missing value again, and we repeat the process on status again. Then lastly, we're going to the unnamed. So here is the unnamed statement, which is falling out with 3 of the missing value, but we draw up the name. Then we print the head again, we check on the missing value again. So we can have a look here. We on here is unnamed 0, it's become 0 already. Then there is no title for the line, for the column of it. Then here is the statement column, then the status column. So next, we're going to our status label, which we count out the status attributes, then see how many categories is there. Since our goal is doing a binary classification, so we will be filter the data to keep the depressions and normal. Then we map depression and 1 to depression to 1 and normal to 0. So here is our sorting out the values. We're showing out the data value here. Here's the normal one, and we print it again since we sort it out already. So according to ascending value here, then we convert it into a binary classification. We do it on here. We're printing out all the value here. Then we're doing like a mapping functions. We make the depression into 1, the normal into 0. Then we print it out to check it again. Then we check again with the value counts of it. Lastly, we visualize a graph here to easily to explain and looking on it. So we can have a look on the normal value here is reaching out of 16,000 of the value. Then depression is almost to getting 16,000 value. Next, we start to training our models. So we import a trend test split libraries from the sklearn model selections. We define X as a statement value, then Y as a status value. Next, we separate the value into 4 of the categories. One is X trend, another one is X test, and Y trend and Y test. We're using the trend test split library, which we're putting in the XY value, and the test size is 0.2 because we try to matching out the real case scenario with the random state 42. Then afterwards, after running, there's nothing happening because we don't print any value here. Next, we import the word2vec. This one is the model which we tokenize all the text together. Then we can make it out into a more numerical value on it. So we're bending all the words into a numerical value, then we put back on the axis, then we put into the data set. And on the next, we do with the sentimental analysis, we getting out a TF-ID vectorizer. So with vectors, we vectorize all the data on the trend set into we just fit it and transform into a suitable range of it. Next, we started to train, This is our decision tree model. We train it out by using decision tree, and then we feed all the X trend and Y trend data into the models. Then we predict out the value. Then we started to print it out the result. Here's our confusion matrix that we build out with SNS, Seaborn, and it's showing out our outcome here. It's quite well on the outcome, so we can have a look on the precision score. Here is like 0.2 and 0.3, and as in the confusion matrix, we also can have a look on the true positive and true negative values. It's quite high here. It's 3034 and 2821, absolutely above the average of all of the data set here. Then the next, we're doing out with we started to drawing out with the RLC curve. We evaluate the decision tree with the RLC curve. As the value closer to the top left, the better the model perform. So we can have a look here. It's almost reaching out all of the 1.0 and the top left there. Next, we're going to the neural network. In the neural network, we're using the SK neural network, which we import the MLPC classifier. So in the MLPC classifier inside this one, we have a neural network. We can train it up. So the hidden layer, we set it out the size 256, 128, and 64. There's 4 layers of it, or 3 layers of it, sorry. Then start from a 256, then 128, then 64. And the activation layer we're using ReLU because we want to solve it into 0 to 1 to better of the understanding of our data set. Then the solver we're using Adams. Then the random state is 42 because it's more natural. Then the max iterations we're doing with 1500. The early stop we're starting with true because to preventing overfitting of a data set. Then we start on the validation fractions that we will validate the data again. Then we fit all the data set into it again. Then we predict. Then we print it out the result and the confusion matrix. So we can see here the confusion matrix is getting the higher score than the neural networks. One is 95 and 96 on the precisions of a true negative and true positive rate. We can have a look here also with the confusion matrix. It's really high value than the decision tree. So again, in the RLC curve, it's more getting to the top left if we compare to the decision tree. So lastly, we implementation on the last question here. We do it out all the statement here. We import as a new data set. Then we transform the data set into a test data. Then we start to decide. This test is we're using the vectorizer, which is the same with the top we do with the sentimental analysis. Then lastly, we predict it again with the decision tree. Here is with the neural network. Then we output out all the result here. So we can see the training result is quite not well here, as it's normal because our data set is too small for it. But however, we can have a look here, like the first one, the decision tree predict 0, but the neural network predict with 1. This is because I think the decision tree is doing not good because the true positive and true negative of the precision score is quite low for it, but the neural network have predict a correct answer here. And on the second here, there 2 is predict with a wrong value, because this should be a depression value. And on the third line, we can see the smallest thing they feel too much right now. So this is a depression. However, on the weird side is happening here because the decision tree prediction is depression is correct, but the neural network prediction is normal. So I think this maybe the column or the decoding is not doing well, so it will cause this situation to happen. And the number 4 is prediction fail again. It can't stop smiling. This is a depression situation, but it's not here. So that's all for today. To summarize, we handle all the missing data, we transform the text into a numerical, and then we build two classification model, decision tree and neural network, and we evaluate their performance and accuracy confusion metrics with a ROC curve. So thank you, and anything just come to us. Thank you, sir.